In this section, we're going to talk about another application of percents, and this one has to do with banking, and it is called the simple interest formula. Interest is the amount of money that we get paid for lending or investing money, or that we pay for borrowing money. So when we deposit money in a savings account, the institution pays us interest for its use. So if you have a savings account and you get interest, usually this is deposited monthly into your account. Basically, the bank is paying you a small fee for letting them hold your money. Because what they do is it doesn't just sit there, they actually use it for other investments and things. So they're using your money to make money. So they're paying you the interest instead. When you have a loan, so when we borrow money, let's say you take out a loan or a credit card or something like that, interest is the price we pay for the privilege of using the money until we can repay it, right? So you're paying that extra fee to borrow the money. The amount of money that we deposit or borrow is called the principal. So for example, if you deposit $2,000 into a savings account, then $2,000 is the principal. Or let's say you take out a loan for $10,000, then the $10,000 is the principal. The amount of interest depends on the principal, the interest rate. So when you hear that word rate, you want to think of a percent. And the length of time for which the money is deposited. In this section, we're going to assume the rate is annual, meaning per year. In the next section, we're going to look at a different kind of interest called compound interest, which is more complicated. Simple interest is as it is, it's more simple. So we're assuming that the interest rate is just calculated only once a year, and that's going to be for the simple interest formula. So simple interest involves the interest calculated only on principal. The formula looks like this. So it's interest equals the principal times the rate times the time. In shorthand, that's an I, by the way, so that's I equals PRT. We tend to capitalize the P and use lowercase r and t, so you'll see that notation most often. And again, R is your rate, which is your percent, and we always reference it in decimal form. You could also do fraction form too, but in banking, we tend to use decimals a lot more. So let's do a few examples. So you deposit $2,000 in a savings account at Hometown Bank. It has a rate of 6%, and we're going to find the interest at the end of the first year. So we're looking for the interest here. So we're using that formula I equals PRT. Now there's no symbols in between, so we are multiplying all these values together. Our principal here is the 2,000. So that's always your starting amount. Our rate is 6%. So our R is 6%, but remember, we don't use the percent form, we're going to use the decimal form. So what we're going to do there is we're going to divide it by 100 to get it into that decimal form. So if you're doing this by hand, your decimal point is after the 6, and dividing it by 100 means moving that decimal point 2 spots to the left. So we're going to use 0.06 as our rate. Now your time, so it's only been 1 year, right? Because we're going to calculate this at the end of the first year, first meaning 1. So we're multiplying by 1 here. All right, and what we get, we're just using our calculator here, so I already have this done. You get $120 even. Okay, so your interest after the first year is $120. So this is the amount that the bank would pay you, again, as a fee for letting them utilize your money while it's in their bank. A student took out a simple interest loan for $1,800 for 2 years at the rate of 8% to purchase a used car. What is the interest on the loan? So again, we're looking for that interest. So our principal here is the $1,800. So it's always the amount of the loan or the amount of money in the savings account. So it's that starting amount. Now we're looking at 2 years here. So our T is 2. And our interest rate is 8%. Again, don't forget, you need to put that in decimal form. So it's going to be 0.08. So we take that number 8, move that decimal point 2 spots to the left. So I have 1,800 times 0.08 times 2 because it's 2 years. All right, and we're going to get $288. So for instance, if that student had this loan, they would have to pay back the $1,800 plus an extra $288 in interest, which again, interest is like a fee. So it's that fee for to the bank for letting you borrow their money, pretty much. Now, one thing I will make note of is that these are just examples. Interest rates really change drastically depending on the year. So lately, you know, in like the late 2010s to 2020s now, our interest rates have been pretty low for loans and also for savings accounts. They tend to go hand in hand. There's always exceptions, but usually when rates are low on loans and mortgages, they're also low on savings accounts. So to actually have a savings account rate of 6% is extremely high right now, or to have a loan rate of 8% is also pretty high. But these can always vary. So your interest rate is really dependent on the bank. It's also dependent on you, the person who's borrowing money, if it's a loan. So if you have better credit scores and you're more of a reliable, financially reliable person, so they look at your financial records and things like that before you get a loan, then usually you get a lower rate. If you're not as reliable financially or you don't have a lot of experience with loans and credit cards and paying them back, then you may have a higher rate. So that's one thing to be aware of with rates is that these are just examples. It's going to depend on that bank and in your own personal credit history as well. Now, one thing I want to note is that time doesn't have to be a full year, right? So we can use a fraction to represent part of a year. So let's say we have a short-term loan for something like 125 days. It's not the full year, and we can express this as a fraction. Now, one thing I want to note is when we're talking about days in a year, it's actually a little bit confusing when we're talking about banking. So there could either be 365 days in a year, which we know is normal, or there's something called a banker's rule where they assume a 360-day year. So you need to be careful. Some banks still use a 360-day year. This was more of an older method that was helpful before we had technology. So 360 days was much easier to work with because we would assume you had 12 months, each with 30 days in them. So it made calculations a lot easier for banks when we didn't have as much technology. Now, because we have so much technology, it's very easy to do these calculations with computers and have programs running in the background that 365 is becoming more the norm, but you do want to be careful to see how your bank does their calculations. So usually things like government agencies, the Federal Reserve Bank, and many credit unions and banks do use the 365-day calendar now, but there are some that still use 360 days. So you want to be careful when you're doing these questions as well to make sure you read carefully to see what they're using for a calendar. So before I move on, so for instance, so let's say we were doing the time here. You could either do it as 125 out of 360 if you're using that banker's rule, or your time would be 125 out of 365 if you're using a standard calendar. So we can still have our time here. Use it as a fraction. So you just want to be a little bit careful if it's given in days. One thing I will note is that the values with 360 tend to be higher, right? Because 360 is a lower number than 365. So when you divide, you get a higher value here. So when you have a loan, the banker's rule works in favor of the bank, not in favor of the person. So it's just something to keep in mind that it tends to give you slightly higher values. It's not a huge difference, but it's slightly higher. All right. So when we have our interest calculation, oftentimes when we pay back a loan, for instance, we have to add it to the principal that we borrowed, and that's called the future value. So we put those two things together. So when a loan is repaid, the interest is added to the original principal to find the total amount due. We can get this value by adding the interest and the principal, and this amount due, we use the notation A here, is called the future value. And the principal P is often called the present value. So if you hear these terms future value and present value is just referring to the principal, and the future value is, we use the symbol A, it refers to the principal plus the interest. Okay. So here's the formula for that. If you have the principal and you have the interest, we can just add them together. The rest of the formula is the same, it's just breaking it down. Remember that the interest is PRT, so they've substituted that value in, and they've kind of given you a shortcut formula here. So if you don't already know the interest, but you need to find the future amount, then you could use this formula here, which is a little bit faster. But if you already have the two values, then you can just add them together. So let's do some examples. A loan of $1,060 has been made at 6.5% for 3 months. Find the future value. So we're looking for the future value here. So what I'm going to do is just use that new formula. Let's give it a try. Because I don't already have the interest, so I need to do the whole calculation. And my principal here is the 1,060. My rate is 6.5%. And remember, we're going to put that in decimal form, so I move it 2 places to the left. So it's going to be 0.065. Now, my time here is 3 months, so it's not a full year. There's 3 months and there's 12 months in a year. So this is the fraction 3/12. When we're doing time, you just want to stay with whatever units are given. So I wouldn't convert this to days or anything like that. If you're in months, use 12 for the denominator. You know, if you're in days, use 360 or 365, depending on what you're told. If you're in weeks, use 52, right? So use whatever unit you're already in. If you want to simplify this, you can. This would be 1/4. So we're going to have our principal, which is 1,060 times 1 plus 0.065 times 1/4. And make sure you follow PEMDAS here, so the order of operations. We're going to do the inside the parentheses first. And let's see. All right, so I'm just going to take out my calculator here just to kind of do the steps along with you guys. All right, so we're going to work inside the parentheses first, and you want to remember with order of operations, we're going to multiply before we add. So I'm going to do 0.065 times. Now, when I do the 1/4, I am going to put it in parentheses in my calculator, so my calculator knows that this is something that needs to be together. And then I'm going to hit enter. Then I'm going to go ahead and add it with the 1. So I now have 1,060 times 1.01625. I multiply that out, and I get, let's come over here, $1,077.225. So dollars are usually rounded to 2 decimal places, right? Because of changes out of hundredths. So we'll make this 23 cents. Now, if your calculator isn't can't do parentheses and things like that, sorry, excuse me, I would do the 1/4 calculation first and just make that a decimal. That may be a little bit easier. So I would divide the 1/4 first and then multiply it by the 0.065. So again, I'm not really changing the order of operations. I'm just converting that fraction into a decimal to make it a little bit easier to do in my calculator. So you can do that too if you're having trouble doing fractions in your calculator. Always use as many decimal places as you can, though. So if you have a weird fraction, let's say you have something like 1/3, use a whole bunch of decimal places here. Don't just use 1 or 2. So you always want to use more decimals is better when you're doing a calculation, and then round at the very end. And you can see that I did that here too. So even when I did my multiplication, I used all 5 decimal places to do my multiplication, and then I rounded at the end. And that's the best technique you want to use. All right. Suppose you spend $4 each day, 5 days a week on gourmet coffee, or really just any coffee. $4 is not really a lot to spend on a cup of coffee. How much do you spend on this item in a year? So let's think about this. We spend $4 each day, 5 days per week. So $4 times 5 days is going to be $20. And this is per week, right? Now, there are 52 weeks in a year. So $20 times 52 weeks per year. We're going to assume that you still get your coffee even on vacation or holidays and things like that. It comes out to be $1,040. Okay, so if you're the type of person that goes to get a coffee, most days of the week, $4 is pretty average, I would think, for most coffees. If you're walking around and and you're going shopping and stuff like that, or going to work, stopping at Dunkin's or Starbucks, that can really add up fast. So you're looking at over $1,000 spent just on coffee during the year, and that's with 1 cup a day, right? So if you're going more often, then you're maybe spending more. If you invested your yearly spending on gourmet coffee in a savings account with a rate of 5%, how much would you have after 1 year? So we're looking for the final amount, right? We want to know how much would you have in that account. Now my principal here is the 1,040. My rate is 5%, and again, we're going to convert that over, so we're going to use 0.05. And the time is just 1, because it's 1 year. So your time is always in years. So we have 1 whole here. We don't need any fractions. So I have 1,040, and then parentheses 1 plus 0.05 times 1. Make sure you're following your order of operations. So 0.05 times 1 is just 0.05, and then plus the 1 is 1.05. And then when I go ahead and I multiply that out, I have $1,092. So the final amount we would have is $1,092 if we took that amount and invested into a 5% savings account. Now, one thing to know, I know this question didn't ask, but how much interest is earned here? So let's say you know the final amount. If you do the amount minus the principal, so that 1092 minus my original value, you can find out your interest that way as well. So if you have the answer and you need to work backwards and find that interest, we can do that by subtracting with the principal. So you can see that you earned $52 in interest over that year. All right, you borrowed $2,500 from a friend and promised to pay back $2,655 in 6 months. What is the simple interest rate you will pay? All right, now this one's a little trickier, right? So we're asking for the simple interest rate. So I don't know the rate here. That's what we're saying. What is the rate? I don't know. I know my principal, though, is $2,500, right? And I know my final amount is $2,655. My time is 6 months. So my T is 6 months out of 12 months in a year, which you can also write this as 1/2 or 0.5. So you can, use any form you want as long as you're using the correct values, right? So if you have a lot of decimal places, use a lot of decimal places. So otherwise, try to use the fraction. All right, so let's go ahead and plug this in and solve. Now, because I have the amount here, not the interest, I'm going to actually use the second formula that we have. But there's different ways you can do this. So if you have another idea of how to solve this, give it a try at home and see if you can get the same answer. So I have 2,655 is my amount. My principal is 2,500. 1 plus, I don't know R, but I know my T, so it's R times 0.5, or 1/2. All right, so I'm going to use my rules for solving. And again, there's different ways to solve this. So this is just one way. I'm going to go ahead and distribute this out. And I'm going to get 2,500 times 1 is 2,500. And now I'm getting 2,500 times, so I know I wrote this backwards, but this is just 0.5 R. So I'm going to do 2,500 times 0.5 R. And I'm going to get 1,250 R. Just using my calculator there. Now think about your regular solving rules. So I'm going to want to bring this to the other side, get those like terms together. And then I'm going to go ahead and divide by this 1250. So I'm getting that R is going to be 155 divided by 1250. And let me see my notes here. And what you get is 0.12. Now this is the rate in decimal form. Whenever we do calculations, it's always in decimal form. So if you want the percent, we would multiply it by 100 to get that percent. So our answer is 12.4%. That's a pretty high interest rate that you're paying your friend back to borrow some money. So that's a pretty high interest rate. Maybe better off going to the bank at that point. All right, let's do one last example here. You plan to save $2,000 for a trip to Europe in 2 years. You decide to purchase a certificate of deposit, which is also called a CD, from your bank that pays a simple interest rate of 4%. How much must you put in the CD now in order to have $2,000 in 2 years? So think about what's going on here. I don't know how much to put in now. Now is another way to think of present value, right? And this 2,000 is the future value, right? Because this is what I want later on in 2 years. So I don't know my present value here, which is also the principal. I know I want my future value to be 2,000. I know my time is 2 full years. And I know my interest rate is 4%, which is going to be 0.04 once I go ahead and convert that over. All right, so I'm going to use my formula. Again, I know the A, I know the T, I know the R, so I'm going to use my A formula here. So I have 2,000 equals to P times 1 plus, all right, now let's see, R is 0.04 and T is 2. Now, twice 0.04 is 0.08. So I have P times 0.08. Now, I know this is written a little bit backwards, so we can rewrite this if we want to. Put the 0.08 first. And then, just move this up. We're going to go ahead and solve. So I need to divide both sides by 1.08. And what I'm going to get is that P is about 1851.852. Now, one thing you want to note here is that a lot of times when we're finding the present value, we round up automatically, because if I round down, or if I don't round high enough, then I'm actually not going to get the full 2,000, right? I would be short. So what you notice a lot of times with present value is that we often round up because we want to make sure we have the right final value here. So, oops, yeah, let me write it up here. So I have the 1851, and then it would be 0.85 cents, but because of that 2 here, I'm going to round this up to 86 cents. So again, it's pretty common to take that when we're finding P, so not for all of them, but when we're finding P, to round up automatically. Because that's why it's better to have a little extra in that account to start with than it is to have less. So if we only put in 85 cents, then we're actually not going to get to that 2,000. We'll be just under it because it's supposed to be 0.852. If you put in 86 cents, what will happen is you'll be just over the 2,000, but it's better to be a little bit over than a little bit under when we're saving money, right? So that would be our value here. And again, something that you're going to see pretty often when we're finding the principal.